Hello and welcome to another YouTube live edition of the ECS DevOps Playground London. So my name is Cameron Harper and tonight we'll be talking about shifting compliance left with Regula. So my name is Cameron Harper. I have been a DevOps consultant at ECS since March 2019. I work right now on a project with a tier 1 financial organisation within the UK, so lots of heavy regulatory compliance there. We're going to be talking about a tool that we picked up to solve some common problems. But first of all, a little bit about the DevOps Playground. So DevOps Playground has been running on YouTube Live since the start of the pandemic. It's an inspiring tech enthusiast to explore new technology during hands-on monthly events. And this month we'll be talking about compliance. Now, compliance is not really the sexiest topic in the world, but like other things such as unit testing and sort of integration testing, it's really, really important, and especially when you look at regulators and financial organisations and healthcare providers. We're going to get to that in a little bit, so let's start to talk about compliance. So, compliance is effectively what stops your project from getting shut down. So, let's talk about some examples of compliance. So, first of all, what's compliance? Well, from regulatory concerns to team tagging, compliance covers all the rules that you need to follow and adhere to stop the project from being shut down. Compliance can be a painful process, lots of manual intervention, spreadsheets, moving stuff around. However, tools exist to automate this pain and keep track of your resources and ensure they are actually compliant. So we're going to start off by looking at some of the big names in compliance at an international level, such as some of the financial authorities, and then we'll discuss some examples about less costly compliance but still important within organisations. And then following that, we're going to jump on to talking about left shift and testing, and then we'll get hands-on with a tool to actually perform all this for us. So, big names, regulators. Now, within the UK, we have the Financial Conduct Authority, which basically regulates large financial organisations, traders, banks. We've got the ICO, which is the Information Commissioner's Office, which controls data protection, making sure that companies that process private information keep that data secure. Over in the States, there is HIPAA, which is the Health Insurance Portability. I can't remember the last of the acronym, but we'll get to it in a second. So let's have a look at HIPAA in terms of regulatory compliance. So the Health Insurance and Portability Accountability Act of 1996 exists to make it easier for Americans to transfer their health insurance between jobs, and also to encourage the use of electronic health records to improve the efficiency and the quality of the US healthcare system. Now, anybody who has done their AWS security specialist exam might be familiar with HIPAA, because it comes up quite a lot when we're talking about AWS compliance. Some statistics about HIPAA. So 96% of companies are concerned about the state of their public cloud security. 70% of companies have experienced a breach, and 29% of these companies who experienced a data breach were due to them exposing data through misconfigurations. These stats come from Sophos, who do yearly state of cloud security reviews, speaking to large organizations all over the world. And we're going to focus on, in our examples, making sure you don't expose data, specifically data stored within AWS's S3 service. Now, we'll speak a bit more about what S3 is later on when we get to the hands-on examples, but many of you might be familiar with some actually very, very public and well-reported breaches, because it seems that pretty much every week there's a new company that has accidentally left an S3 bucket containing private information of their customers public. So perhaps one of the most devastating ones happened back in 2017 when a company called Alteryx had a publicly exposed S3 bucket which contained private information, private identifying information, or PII, of 123 million Americans. So effectively every single household in the United States had their private information breached by a simple misconfiguration of an S3 bucket. More recently, in 2019, Authentic Jobs, they exposed 220,000 CVs, again for a misconfigured S3 bucket. And in the past couple of months, you might have heard about Premier Diagnostics, an American health company which exposed 50,000 users actually healthcare information. With these comes usually very large fines. So I mentioned before the ICO in the UK. I think the minimum fines are around £17.5 million if you expose customer data, or 4% of your annual worldwide turnover. And HIPAA fines as well are very, very expensive. Per violation, they can range from about $100 to $50,000, and that's per record. With a penalty of, I think it's maximum 1.5 million in sort of event of a large scale data breach. So it gets very, very costly for making very, very simple misconfigurations of your infrastructure. Less drastic now, we're going to talk about some internal compliance and look at tagging standards, which will be the final exercise of the playground. So tagging is effectively a way that you can attach metadata to resources deployed in public cloud providers such as AWS, GCP, or Azure. They help keep track of ownership, cost centers, and which versions are deployed, and any other metadata you need to attach to a piece of infrastructure. As I mentioned, it's not as risky as breaching regulatory compliance, but it's still important to keep track of your own assets, especially when it's enforced at an organizational level. So let's talk now about testing. Compliance, I think, actually fits into testing. So we're going to cover off sort of some concepts. So traditional and left-shifted testing. So let's have a look at some traditional software development lifecycle test strategies. Now, the image was taken from bmc.com, who have a fantastic article about what left-shift testing is. But effectively, within the traditional software development lifecycle, as you can see here, you spend most of your time and your effort and your actual testing budget later on in the project. So you start off by writing your requirements, doing your designs, doing your development, and then finally perform your testing. This is, testing performed after software has actually been implemented. And when you're performing testing in this manner, catching bugs is extremely costly. Reworking requirements especially could cause significant costs and delays. So again, testing later on in the software development lifecycle, it makes it really, really hard for you to go back and change things and actually fix problems, which you could have caught earlier on. So in terms of compliance, I've listed a couple of services here which perform something called asset monitoring. So effectively, it's compliance on the right of the SDLC lifecycle. So two AWS examples here. So there's AWS Trusted Advisor, which is a fully managed service provided by AWS, which looks at sort of compute instances, databases, and runs a built-in set of rules against these, which can actually give you some advice about how you can save money. You can increase the security of your resources, keep stuff up to date, roll out patches, all that lovely stuff. AWS Config is quite similar, however it supports a much wider range of resource types, and it also allows you to implement your own custom rules using AWS's Lambda function service, where effectively you can say, hey, for every single resource of this type, go and evaluate it using this Lambda, where it sends off a resource identifier, it'll process that, look at the attributes applied to that, and it'll either send a response back saying, hey, this is compliant, everything's fine, or there's an issue here, you need to go and fix that. And it'll flag it up and allow you to record these changes in compliance rules over time. Outside of the AWS ecosystem, there's another platform, which is a SaaS provider called Jupyter-1, which performs very, very similar sort of functionality to AWS Config. However, obviously it's not an AWS service, and it supports a much wider range of service providers such as GCP, Google's cloud platform, Microsoft Azure, and allows you to implement compliance checks as a set of no-code rules, which some people who aren't as savvy with implementing, say, Lambda functions themselves, would be much more happy to actually pick up an easier-to-use language, which is provided by Jupyter-1. Now, why don't we actually perform compliance testing before we deploy? Because it gives these sort of benefits here. If you look on the right, we've got this diagram, this shift-left model, which is where you actually start implementing your test cases before you even implement any code, which is a thing called test-driven development, which we'll get to shortly. But in adopting this kind of model, you get faster feedback, you can move fast and you can break things. You can introduce quality gates for automation, and you can save time and ultimately money on making changes, because it's a lot easier for you to detect a bug on, say, day 7 of your implementation than after you've actually deployed your application to production. Because if you had to rework your requirements to actually meet the changes needed to actually meet that case, then it can become extremely expensive if you've already actually gone and implemented this and released it. So left shifting is basically taking the testing that was performed after you've released your product or before you release your product and you've already implemented it, and performing this from day 1. Adopting a test-driven development or TDD approach is where you actually go and implement your test cases before you even get to implementing any of your actual code. So we want to be able to test our changes to make sure they're compliant as we implement them. We want to prevent issues which can be introduced by late testing, and we want to adopt a test-driven development approach. And the way we're going to do that tonight is we're going to look at at automatically testing all of the things. So to do that, we're going to be working with infrastructure as code, using a tool called Terraform, using the AWS cloud provider. Infrastructure as code is, again, it's quite a modern trendy thing where previously you used to be able to physically build servers, but you manage yourself, and that was costly. You had to run your own data centers, manage patching, all these cumbersome things. And then came the public cloud providers. So I think in 2008, Amazon Web Services launched as probably is still the biggest public cloud provider, where you effectively could move the physical management of servers, and instead of that, you'd rent virtual machines off AWS, where you pay them a monthly bill for the resources you actually required. And at launch, AWS, you had to log into a console or use an API to actually go and provision your resources, which again includes room for like manual error. It's not really repeatable if you have to click and copy and paste things between consoles to actually stand up a piece of infrastructure. And it makes it difficult to test in different environments. So that's when infrastructure as code came along. Now, obviously there are other infrastructure as code tools available, but perhaps the most popular is Terraform. It's definitely the one that I'm most experienced with. Terraform allows you to implement your infrastructure using a superset of JSON, which again is an extremely readable sort of data language, which a lot of people are familiar with. It's nice and clean, easy to see what you're doing, and it supports a wide range of providers. But one of the key benefits of adopting infrastructure as code is repeatability, version tracking, so you can keep all your infrastructure configurations within like a source control like Git, which again developers are already familiar with. But you can also start performing actual pre-deployment testing. Some of this can actually perform through static code analysis, which is what we're going to do today. So you don't even have to actually run any Terraform code or the Terraform tool itself to be able to perform your test within that. And that's what we're going to be looking at with a tool called Regula. Regula is a validation tool we'll be looking at tonight, which is an open source tool, which is, I think it's produced by a company called Fugue. But the source code is all available on GitHub. You can raise feature requests and your own pull requests if you want to. I'll provide a link to that after the actual presentation. Now, Regula uses another tool set, which is called OpenPolicyAgent, which is a very, very widely adopted way of implementing compliance checks for infrastructure as code. And it uses a language called Regula, which is a logic-based language. And I'm not really sure if you're not as savvy with sort of logic or functional programming as I am, but don't worry, we've provided you all the code you need to actually perform the playground within the Git repository. So, now that we've done talking about the toolchain, we're going to have a look at the exercises we're going to run through tonight. So we're going to start off by just walking you through the repository structure. I'm having a wee nosy at the Terraform files which have been provided for you. So we'll have a look at the resource types which are used. Then we're going to start actually using Regula, which provides built-in checks for AWS. So we'll review a number of these using some provided Terraform, just so you can get a feel of using the tool, having a look at the output, and seeing how you can implement changes in Terraform, rerun your tests, and then see if they're compliant or not. After that, we're going to move on to exercise number 2, which is HIPAA S3 compliance, which again is a real world example, which I should say there, which will make sure that our S3 buckets are private and versioned. And this effectively make sure that we don't break any of the data. So versioning is very important there. So if we say overwrote a piece of customer information with something that was invalid, it's really useful for you to be able to go back and restore that previous version. And finally, with S3 buckets, as I mentioned before, it's very easy for you to misconfigure a bucket to say, hey, make this public. So what we're going to do is we're actually going to enforce that we have the private default settings enabled in S3 buckets, so we don't find ourselves in a situation where we've leaked the private information of basically every household in the United States. Finally, there's a more complex example to look at tagging standards, which supports a wide range of AWS resources, and this will probably be given to you guys as homework. I'm not really sure if we'll actually make it to there tonight, but you never know. If we finish off quite quickly, we might be able to perform this example live. So, you should be provided with a link in the YouTube description and a username, so head over to there and you should be able to open up your terminal, and we'll actually get started with the hands-on part of the playground. So, I'll give you guys a wee minute to just get sorted. You should have a link to an IDE, like my one here, which is where we'll be actually performing all the changes to the files, and we can have a browser around here. And then on the right here, I have my Wetty terminal, which is where we're actually going to run the Regula command. So you should be launched in the root of the playground, which will have a directory called work there. What you should do is type, actually let me just zoom in here a wee bit to make sure that's easy for everyone to see. So we're going to start off by just making sure we're in the correct location in our terminal, and we can do that by typing in cd for change directory and work there. You can run the ls command here to list the files, and you can see in here there's a link to the Git repository, dpg 2021 July Regula. Now, if you're used to using VS Code, you might be tempted to actually just open up the built-in terminal within VS Code, within the sort of server version here. However, Regula is not actually installed in here, so you need to perform all the command line commands within your actual terminal environment. Sorry about that. Caught me the first time around for that as well. But let's start off by jumping into here, and we can actually start having a look in here. So when we root the playground, you've got a couple of files here. So there's the readme, which we can have a look at. I'll probably just view these in GitHub so we can see the nice rendered markdown file. So let's just open up the readme first. Just a bit of information here, but we're going to take a test-driven development approach by implementing tests and then making changes to our code base to make sure we meet these tests. So to get onto the first exercise, which is 001 built-in rules, just scroll over to this directory here, 001, and click in here. So you should have a readme and a folder called tf. There's also a script called run.sh. If you're quite lazy, you can just run that script. But we'll print out the full Regula command so you guys can see it in my terminal here, and I'll run you through what all the options we're actually using to do. So this exercise, we'll be looking at a set of Terraform resources, which we can look at here. Now, Terraform looks for files called anything.tf. So tf is the Terraform file extension. Let's start off by just having a look at the CloudTrail.tf resource. Now, what you should be able to see is, as I said, it's very similar to JSON, but Terraform uses what are called blocks, and we're going to use a resource block, which means we're actually defining a resource that we want to provision using Terraform. The first item after the resource block definition there is the resource type. Obviously starts off with a prefix of the cloud provider or provider we'll be using. So in this case, we're using AWS. And the resource type within AWS here is CloudTrail. After this, we have what's called a logical name. which is what Terraform uses to reference that resource itself within the Terraform code base, which means you can actually reference attributes and parameters from other resources within another resource within Terraform. Like you can perform some interpolation if you need to, just build out sort of domain names. You can perform, I think, basic logic now. It's a Turing complete language, I think now. I work with somebody who actually produced Game of Life within Terraform, so it's a really, really powerful programming language in itself now. Not that I see many use cases for doing any advanced sort of programming within Terraform. Obviously, what I use an actual dedicated programming language for that, but we're going to be stick to using Terraform for its original use case, and that is provisioning cloud infrastructure as code. So we have a resource here called AWS CloudTrail foobar, and then underneath it are the parameters. So the first parameter here is called name, and this actually refers to the AWS name of that resource. So I mentioned before, this resource within Terraform is called AWS CloudTrail.foobar, but within AWS, once it's actually been deployed, the resource would have the name tftrailfoobar. It has three more arguments here, parameters should I say, an S3 bucket name and an S3 key prefix, and then an option to include global service events, which is set to false. Now, AWS CloudTrail is a tool for recording API calls within AWS. So every API call you make to a supported service within AWS, if you have CloudTrail enabled, CloudTrail will actually put this into a log. Within CloudTrail itself, it records, I think, 3 months of API calls, but you can specify a S3 bucket here, and CloudTrail will actually go and store those log files within the S3 bucket. These might seem quite familiar to you if you've used Terraform before, because in most cases I have just lifted examples from Terraform's own documentation. So if you go to, say, the Terraform registry documentation for AWS CloudTrail, you will just see this example again here for tftrail foobar. The way we're going to perform this first exercise is I'll run you through the Terraform code, first of all. And you can see on line 7, we have what's called a commented line, which this hashtag here basically says for Terraform to ignore this code, but still include it in the file. Which is useful for disabling and enabling functionality, leaving comments that explain what the resource does and explain design decisions. But what we can do is we can go and remove this hashtag, and that will actually enable that line. Why we want to do that is because we are going to be playing around with Regula's built-in tests. So if we go back to 001 here, we can scroll down and have a look at this large table here. So let's bring that out a bit here. So this effectively lists every single built-in rule that Regula ships with for AWS. We're not going to be messing with every single one of them because there's some quite complex resources such as CloudFront, which just effectively mean you have a huge file and it'll probably get a bit confusing. But we're going to look at some simple examples here. And then we're going to go back to the Terraform code. We're going to uncomment out that line, which will actually fix the compliance rule and make it compliant. So let us just go in and run our first Regula command. So included in your markdown file, which you guys should be able to see, is this command here, which will look very, very similar throughout each of the exercises. But what it says is Regula, as in calling the tool here. So let's try that to start off with. We can see the available command. So there's help, there's REPL, which starts an interactive session. There's run, which is the one we're going to be concerned with in this exercise, which will evaluate rules against infrastructure as code with Regula. There's show for showing debug information. There's OPA testing. There's printing out versioning information, and then there's some write test inputs, which I don't even know what that does because I'm not extremely an expert in using Regula. I've only just sort of adopted it myself in the past few months. We're going to use the run command, which will evaluate an input directory of infrastructure as code. For us, this will be Terraform. However, Regula supports, I think there's CloudFormation on AWS, Kubernetes sort of charts and stuff like that as well. So it's got a wide range of services it supports, which you can actually implement compliance rules for. But we are just going to be using the AWS built-in rules for exercise 1. So over on our terminal, let's hop into directory 001. Again, use cd to change directory and make sure you are sitting within workdir /dpg 2021 July Regula /001. So let's just have a little browse of the files in this directory just to make sure we're in the right place. Now what we can see is the readme here on the left, the run.sh command and the tf directory. Well, I'll go have a look in the tf directory. We just looked at that within GitHub and you can view that in your own IDE, but we're just making sure we're in the correct place. So let's start this off by, first of all, we're going to run Regula with just the option, the input tf to run. We're going to see what happens. Now, this isn't very readable. This is the default output format of Regula is JSON, and this is really useful and really powerful. So if you do adopt Regula within your continuous integration and deployment pipelines, it's useful for you to output stuff in JSON format because it's machine readable. So if your results are output like this, then whatever tool you're using, say Jenkins, can read the output and it can actually logically decide what to do next. It can raise alerts, it can look at the severity of the individual cases and say, okay, you've got 10 high failures, you've got 1 low failure. That's pretty bad. But if you've just got 1 low failure and everything else is passing in your critical rules, maybe a label misconfigured, obviously that's quite bad, but it's not as bad as, say, oh, I've left my S3 buckets public and it contains 200 million Americans' private data. So let's make this a bit more readable. So what we're going to do is we're going to add this option in now for format. And we're going to use the value table. And what we should see now, let me just drag this out a wee bit. Actually, I'm going to put you in full screen and zoom out a little bit so we can get a better look here. And let's just move these over here. So we've got this nice readable table format now, and I'm going to run you through what each column means, and we'll start looking at each row, and then we'll actually go ahead afterwards and make all these rules compliant. So, starting at the top, the CloudTrail resource that we've already looked at within the Terraform code, called foobar here. It's of type AWS CloudTrail. It lives in this file path tf, which is the directory it's contained in. And it has a severity, and that's medium. Sorry, I've just been informed my webcam's in the wrong place. Let me just move that up here. So you should now be able to see the table a bit better now. Thank you for that one, James. So let me start that one again. So looking at this top resource here, we can look at AWS CloudTrail.foobar of type AWS CloudTrail, which lives in the file path tf, and this is a medium severity rule. So severity is quite an obvious label, which basically says how big an issue is this. And like I said before, you might have some sort of labeling rules, which will be low severity. So again, it's not really required, but it's nice to have for keeping track of things. And then you get stuff like high, which basically says, is this public? Is this not encrypted? That's pretty bad. So this gives you this sort of idea where, say you had implemented tests written that runs these compliance checks over an existing set of resources, and what's spat out of that is a big list of uncompliant resources and failing rules. The way you'd probably prioritize how you would go and resolve those is by just doing it based on severity. So you go in first and make sure you fix the public data breach, and then finally, once you've gone through the highs, the medium, and the lows, after that you resolve all your labeling issues. So back to this rule here. This is called TF AWS CloudTrail log file validation, and it includes a message which says log file validation should be enabled. And then afterwards you can see the result. And you can see there's 5 failing tests here. There's 1 passing test, and the overall of this is a fail. So what the overall stats does, it looks at every single rule, and it will say, oh, okay, so you've passed these 7, but you're failing in this case. Okay, overall it's a fail. So let's start by going and having a look at our AWS CloudTrail foobar resource, and we're going to enable log file validation. And we're going to go back and we're going to rerun our test and have a look at how this will now pass. So to make this compliant, let's first of all go to our IDE. You guys should all have your own one. We're going to click through 2001 and we're going to go into TF. So this directory, like we said, this includes all the Terraform code. So we're going to start off by opening the cloudtrail.tf file here. We're going to ignore this down the bottom right. So let's just close that little guy so he doesn't annoy us when we open more Terraform files up. So like I said before, we've got this line 7, which says to enable log file validation, which basically tells CloudTrail that whenever it puts a log in S3, it's going to generate a digest of it, and that digest can be used to validate the log afterwards to make sure that nobody's tampered with it. And to enable this, we can just go ahead and remove this hashtag. So let's just backspace that twice. It's a standard key to save, I think, so it'll be Command S on a Mac and Control S on a Windows or Linux device, depending on what you're using. So once we've actually gone ahead and updated this file, let's go back now to our terminal and rerun the test. So you should now be able to see, now that we've enabled log file validation, that the test FGR00027 on AWS CloudTrail.foobar is now passing, and that's because we've actually gone and enabled log file validation. So you should be able to see now that what we can do is have a look at the Terraform code first, go back and evaluate the rule, and then once we actually identify what we need to do to make it compliant, we can go and make that change. So for the second example, we're going to be looking at an Ebs Volume, which is the Elastic Block Service tool within AWS. So Ebs Volumes are effectively the SSDs or the hard drive of your virtual machines. This rule here is to ensure that they are encrypted, and we are failing. So let's go ahead and open up the ebs.tf file, which should contain this resource, and have a look at the code. So open up ebs.tf. Now you can see here we have a AWS Ebs Volume resource type called example. It's got a few parameters already set, so it says the availability zone that this will be deployed to, which is set to US West 2A, and a size of 40. Pardon me. Additionally, we've included a tag with name equals hello world. So if you went and deployed this to AWS, if you looked at your volume, you should be able to see a name called hello world. Finally, on line 9, you should see the encrypted equals true parameter. And this one here, if we go and remove the comment again and save that, what this is doing now is we're saying that this volume, when it's deployed, should be encrypted. So we're going to enable encryption. So let's go back to our terminal again and press up to pull up the last command we ran successfully, and then press enter. So we can see now that we have made the Ebs Volume rule on that resource compliant, which means that resource is compliant and it's encrypted, which is good. You can also see here that sort of for the there's a nice color display which goes out here as well. So you can get pass is green obviously and red is fail, but when you've got a passing rule, it's just going to be white, but when it's high you get the big scary red color, and then underneath here medium, which is a bit more tan, sort of less drastic. So, we're going to look at the I am policy exercise next, or the example next even, which is a bit more complex. And this sort of demonstrates how Rego and Regula can be used to evaluate not only just the sort of first level arguments which are attached to a resource, but also like deep dive into the actual values of those themselves. For anybody who hasn't used I am before, it's AWS's Identity and Access Management Service. If we scroll over to here, I am effectively provides permission sets for users and service roles, and actually AWS services themselves across the AWS ecosystem. So it's based on like principles and policies, where we have a policy, which policies are implemented in JSON, which sort of look like this one here. And they are made up of a list of statements. And statements can get quite complicated because you can include stuff like conditionals and stuff like that, but we've got a simple example here with only 3 parameters within the statement itself, which is to say the action, the effect, and the resource. Now, effect is quite simple. It's either deny or allow, where basically if you have no policies attached to something within AWS, it's explicitly or implicitly, should I say, denied. So effectively the default is a deny. Above that, you can allow something, so that'll be an explicit allow. And then finally, you can do something which we can see an example of down at the bottom here, which is an explicit deny. And the order of operations here is starting off with no sort of statement means deny. If there's a statement that's allowed, then the permission is allowed. And finally, if there's a permission that is allowed, but there's a permission which is denied, the deny will override any of the allows. So what this is saying up here within this basically allow all is saying for the action wildcard, which effectively just means anything, and the resource wildcard, this policy allows you to do whatever you want. So it's effectively an admin policy, meaning there's no restrictions on what you can perform. Up the top, we've got a description and a name and a path. Again, these are more sort of metadata, resource naming with AWS. Conversely, down the bottom, we have a one which says deny all. So if you put these two together, you wouldn't actually be able to do anything. So let's just jump back to our rules for a second. We should be able to see, okay, so this I am policy should not have full administrative privileges. And then you can see for the first resource, basically allow all, this is failing. But over in the basically denial, Regula's actually gone in and it's evaluated exactly what permissions have been applied through I am. So to go and make this one compliant, what we can actually do is provide an action. So what we're going to do is just say that person can use the S3 service to, let's just go with put object. I will allow this policy to say that whoever has this policy applied to it, whether it's a user or service role, can put a object into any S3 bucket in any location. If we go back now, we can rerun our rule. Again, press up and press enter. And you can see now that because we are no longer just giving permission to do everything with AWS and we're only specifically doing one action over anything, although this is overly permissive, it's still compliant with this rule here, TF AWS I am admin policy, because this rule specifically looks for the case where you've been given a wildcard resource and a wildcard action, and then they are set to an allow. So let's move back to our table now. Let me just get rid of that pesky doc. What we've done now is we've taken 3 of our cases and we have gone and made a change to make them compliant. So let's just go ahead and clean up these last 2 resources, and then we'll move on to the next exercise, which will be where we actually go and implement our own compliance rules using Rego. We'll take a brief pause after we've finished off these 2 resources in case you guys have any questions. So the team of Panda helpers will feed these back to me. and if not, we'll just jump straight ahead to the next exercise. So our final two resources we need to make compliant is an AWS Key Management Service key called A, and then an AWS S3 bucket called Bucket, or My Bucket even. So let's go and first of all open up KMS. So AWS KMS is the key management service which provides different types of encryption keys. For most of the encryption types supported, you can do something which is called key rotation, which basically automatically rotates the key material every year, so it effectively keeps it fresh, re-encrypts the sort of data that's encrypted with that, and it means that if your keys are compromised, then I think this should actually help remediate that. You might need to read back into a bit more of the details about effectively what key rotation does, but basically it regenerates it every year to keep your keys fresh. So I think this sort of helps with prevent data breaches in the event of an encryption key is leaked. So we have a key here, which is quite simple, has a description of KMS key 1 and a deletion window which says that if you go and delete this resource, it will still be made available for 10 days. I don't know if anybody's been in the situation where you've deleted an encryption key before which was required and you couldn't restore that. I can say I have. It's not very pleasant. So AWS provides this functionality which says, okay, you've deleted this key, but we're actually going to keep that for X amount of days, just in case you do still need it and you've deleted it accidentally. I would have really appreciated that, but oh well. Now, less complaining about past mistakes. Let's move on to enabling this key rotation. So again, just remove that comment, save the file. Go back to our terminal, and we should see now that the KMS key rotation should be enabled. Rules should now be passing. And would you look at that? It is. So one rule remains. This is to make sure that server-side encryption is enabled on S3 buckets. Now, server-side encryption on S3 it can be quite complex, so you can set up multiple rules. But just to keep things simple, we've gone and given you, again, like everything else, the implementation here for you. So effectively we've got my bucket here, which is called within Terraform my bucket, and the bucket name of my bucket as well, underneath the s3.tf file, with this server-side encryption configuration block in here. You can see there's a sort of difference between where you set like an equal sign here and then when you've just got blocks, and what blocks do is they allow you to provide more than one of these values, so you can set up multiple rules for encryption. I think it's based on sort of prefixes, so you can say within your bucket stuff should be encrypted within this key, and then stuff should be encrypted within this key in a different location within that bucket. But yeah, we're just using quite a simple example here, where we're going to apply default server-side encryption using this algorithm. So SSE algorithm means server-side encryption algorithm, and AES256 is telling S3 that whenever we put an object into the bucket that doesn't have any overriding encryption configuration, it's just going to use S3's own encryption method to go and encrypt these. So let's just delete these. I'm deleting twice because I do like my Terraform to be properly formatted, even if I'm not actually going to be deploying it or saving it later on. So let's just go and delete those comments. And finally, let's go back to our terminal, and when we run the test now, we should be able to see that everything is passing. So this gives us an overall pass for all our tests. We can go and, for the sort of savvy Linux people here, I think if there is an output code is actually given by Regula. So if we go and comment this line out again and make one of our tests fail, you can go and have a look at the return code of the command, and I think this should be non-zero because something failed. Again, this allows you to sort of programmatically view the results of the tests, whether in your CI pipelines or if you've got like a big makefile locally, which says, okay, do that return the OK code with 0? That means we're all good. Oh, and you can see there, we've got a 1, which means something went wrong in our tests. Now, if we go and re-enable this, press up again, you can see that it's now giving, oops, let's rerun that, should I say. You can now see that because everything's okay and all our tests are passed, we're actually receiving a 0 command. So again, if you had that in a sort of bash script which said if tests pass and you get a 0 response, give us an email saying, oh, everything's good. And if not, you could send the test report through to somebody saying, oh, go and fix this straight away. So that's wrapped up the first exercise. I'm just going to pause now for a second to see if there are any questions. So I'll just check in the Teams chat. And if not, then we'll just crack on with exercise 2. I think we are all good. Let me just double check. But yeah, if not, let's just jump on to exercise 2 now. Oops, James is typing. Not seeing any questions. Fantastic, easy for me then. So what we'll do now is we'll just go back to the base of our repository, and we're going to go into 002 HIPAA S3 now. So let's step in it here and have a look at the README. So again, introducing the Health Insurance and Portability and Accountability Act of 1996, which just rolls off the tongue. It's legislation which makes it easier for Americans to move their health insurance between employers, I think, but it also sort of encourages the sort of adoption of electronic health records and sort of, I guess, well, dictates, but sort of gives guidelines on how you can keep this encrypted and private and make sure you don't have any breaches. Part of the actually, I think all of HIPAA compliance with AWS is available through AWS's I guess the Cloud Artifact, something like that service. The Artifact service, which basically has lots and lots and lots of compliance guidelines and frameworks. You can read up on all the HIPAA standards and how you can ensure that your AWS stuff is compliant by reading that documentation. We're not going to subject you to the entire thousands of pages of HIPAA guidelines, but we're just going to look at 2 example rules that we should be following from within here. We're going to be using S3 as our resource type again. Again, S3 is the simple storage service, which is object-based, whereas objects are just pieces of data, and objects are stored in buckets. Now, in our Terraform directory, you should just see again, there's a main.tf file in here, which if we have a look at it, there's some Terraform information at the top, so you can just discount lines 1 through 13. Even though we're not using the Terraform tool itself, I still thought it'd be good to just actually include valid Terraform, just in case anybody wanted to pull this code and deploy it themselves. So effectively this just says for Terraform 13 and above, we want to use the AWS provider. And yeah, finally, what we're actually interested in here on line 15, starting off, is our S3 bucket. It's got a prefix this time round called dpg Regula, and what this will do is it will just create a bucket with a random string at the end of it. So this is actually fully deployable. The examples before you might have an issue with because it's got a fixed name, whereas S3 is like a global service, so the namespace has to be unique, so you can't have 2 buckets with the same name. Terraform provides you with this prefix functionality, along with like a lot of different resource types as well support this, but this just says, okay, I want dpg Regula to be my prefix, and I'll chuck out 32 random characters at the end just to make that unique. Now, as this isn't sort of a Terraform focused playground, we're just going to move back through here now. You should see as well, this time round, we have a policy directory in here. It's empty right now besides a readme, but we're going to actually now create 2 Rego files, which is the Rego language built by OpenPolicyAgent, which is used by Regula. Oh, I guess quite confusing. All of this is documented on Regula's website, and you can read more about the OpenPolicyAgent there as well. I think if you go to the README and the basic repository, there should be links to go look up more Regula, but if there's not, I will update that once the playground's complete, and you can go read your own documentation. You can, as I said, you can go read the code as well. For every, as it's open source, for all the rules we played with before in the first exercise, you can actually go and see how these are implemented. So yeah. But less about the built-in rules. Now we're actually going to go ahead and implement our own 2 custom rules. So we have implemented a prefix here called DPG HIPAA S3, which again, DPG, DevOps Playground, HIPAA, Health Insurance Portability and Accountability Act, S3 Simple Storage Service, and then finally ACL, and then the second rule is versioning. Now, I'm not going to go into a lot of depth about what ACLs mean here. If you do want to read more about it, you can open up the S3 Markdown file here, which gives you the links to the documentation and a bit more information about ACLs. But effectively, all we need to know right now is they are access control lists. And these can be, again, quite complex, but AWS provides you with canned access control lists, which basically say, hey, I want things in here to be public, or I want things to be private, or I want people to be able to read information from here but not write it. Let's actually go have a look. So this big table, which says, specifically we're caring about this private ACL here, which says owner gets full control and no one has access rights apart from the owner of the bucket by default, which is really, really good defaults that you won't have enabled unless you have sort of a bucket that you're using to host a website, in which case it makes sense that that'll be sort of public read. But again, we're operating under the use case that our bucket contains privately identifying information, healthcare information, stuff like that, where we want to retain that or remain that private. So yeah, the first rule is looking at access control lists, and then finally the second rule we're going to implement is versioning. Versioning's a lot more straightforward. It effectively says that for every object that is replaced or deleted, just actually retain that, unless you go and specifically delete that version, which is it's a form of backup basically. So to create our first rule here, we're going to create a new file. We're going to call it HIPAA S3ACL.rego. So let's go and open up our IDE, and then we're going to go to this directory, which is HIPAA S3, and we're going to open up policy. Now, we're going to create the file just by pressing this new file button up here, and let's paste in that name because we are lazy. And now let's go and have a look at the content, which should be down here. I'm going to copy this all in here now, and then paste it into here. And I'm going to run you through using Windows shortcuts there, not Mac shortcuts. So let's just step through this line by line, and then we will set up the version rule, do the same again, and then we're going to have a look at making our infrastructure pass. So each line here has been commented just to sort of describe what's going on, but you can use packages within Rego, which say you've got packages of rules. In this case, we have a package called rules, and the rule is called HIPAA S3ACL. And then we have here, this is specifically, this isn't specifically for Regula actually, this is Rego Metadoc. And you guys should be able to recognize some of the sort of attributes here. So an ID, a title, description, and a severity. So let's go and have a look at our sort of built-in examples here. You can see severity, rule ID, rule name, and message. So yeah, that sort of just maps directly into here. Where the ID is DPG HIPAA S3ACL. The title is S3 buckets must have a private ACL enabled. We've got the same description there as well. And then finally this custom severity. And I think the custom Metadoc data is specifically for the end tools that use them. In this case, we are using Regula, which supports Severity. So we're actually going to apply a custom severity of high to this rule because, yeah, I think keeping your S3 data, S3 buckets private is pretty high severity. If in the event of a data breach, actually we probably should just use critical for this. So go ahead and change this to critical. Let's move back to the rule. So line 14 just says which resource types are in scope of this rule, and this will tell Regula which of our infrastructure's code resource to actually evaluate compliance on. Yeah, we're just going to be using an S3 bucket here. Now this is where the logic comes into it. So by default, we want to say that the rule is failing, and it will only be succeeding once we've actually confirmed what we're looking for. And we can perform this logic here on the output allow by saying, is the input ACL, so the ACL parameter attached to the S3 bucket, is this set to private? And if this is set to private, the value of allow will then become true and the rule will succeed. But if this isn't set to private, or if it's not enabled, or it's not present, this won't actually succeed, and it will reward us if the bucket is public. So let's go and save this and perform the same operation now to set up. Oh, actually, I forgot. Let's go and have a look at our output first now. So we can go back to our terminal now. Let's do cd ... and I'll just move us back to the root of the repository. We're going to move now by doing cd 002 HIPAA S3 with dashes, and then let's make sure we're in the correct place. And this time around, we're going to use, oops, thank you for including the new line character in there. But we're going to use this option U, and what this does is it tells Regula to only use user-provided rule sets, and then we're going to pass in an include value here, which is to include the policy location, which is where we've just stuck our rego file. And again, standard as before, we're going to run over the TF directory, and we're going to output this as a table. And now that we actually go and execute this, we can see we've got a rule called HIPAA S3 ACL. It's got an ID here and a very, very scary red critical severity. So there we go. S3 buckets must have a private ACL enabled has failed. So we've got an overall fail there and a big scary critical severity. Now let's just go and do the same to enable our versioning rule, and then we're going to go and change our S3 bucket to be compliant with these. So save again, create a new file underneath the policy directory called HIPAA S3 versioning.rego. Let's copy this content into here. This time around, again, it looks very, very similar. You get your package name at the top. This one has just got versioning as the suffix, same with the ID, the title, the description, self-explanatory, must have versioning enabled. We're going to keep the severity as high because although, again, it's not backing up the data, it's probably less critical than it's totally public and everybody can just go and download anybody's health information. Similar as before, we've got this default allow, we've got a resource type S3 bucket, but here we are just looking at this versioning input parameter here. Now, versioning actually looks a bit different from ACLs within Terraform, but effectively it has the same sort of, but in this case it's a Boolean example, so instead of comparing it to a, actually let's get rid of this line here because that's incorrect. Ensure that the value of input versioning is set to true to confirm versioning is enabled. So yeah, a Boolean value can either be true or false. So what we're just going to say this time around is that the value of allow will always be the value of input versioning. If versioning isn't enabled, as in specifically isn't included within the S3 bucket, by default it's going to be turned off. So versioning is only enabled if it's actually been explicitly enabled within the bucket configuration. So let's just go back to our README now, which will tell us how to make these rules compliant, and then we will wrap that up by having moved from a high and a critical failure, which we can go and actually evaluate by moving back in here. And we can see our second rule in here with severity high, which looks a lot less scary than the critical severity failure there. But again, just as we've inputted into the Regula file, we've got our rule ID, rule name, and message. Here it says we now need to enable private ACLs and we need to enable versioning. So let's go ahead and do that. Over in the README, what we can do is we can have a look at what we need to make the changes be here. So got a bit of information from the Terraform documentation about ACLs and the arguments that we're actually going to provide, but we have just given you the code you need in here. So let's just go and copy and paste this ACL equals private. This time jumping back into our Terraform directory to the main.tf. Let's create a new line in here underneath the bucket prefix and add ACL equals private and save that. Now we can go back to our terminal, rerun this command, and we should now see that our big scary critical warning is actually passing. So it's not the scary block red anymore. So we made that pass. So 1 out of 2 compliance, and let's just finish that off. By scrolling down, we can see how to enable versioning now. So I'm not really sure why Terraform decided to do this. Versioning I don't think has many other options to it. Oh, actually it does. That makes a lot of sense. I was wondering why this isn't just a boolean value called versioning equals true, but it actually allows you to set this other option here for MFA deletion, which we're not going to concern ourselves with right now. We're just going to copy and paste the lines of code here to enable versioning to our S3 bucket resource. And then here, so correct tab. Let's just clean up that formatting a little bit and then save the file. And now when we go back and rerun Regula, we should now see that both of our custom rules are now passing. So that sort of wraps it up from exercise 2. As I said before, there's a third example within here. If you want to go and play around with this yourselves, you can go back to the compliance codes root and have a look at tag sets. Tagging standards is quite important within organizations to keep track of costs, ownership, which teams and versions of components are deployed. So this rule actually supports a wide range of resources, which you can see here. It's a big list. So yeah, if you want to go and have go ahead and play about with some tagging resources, feel free to do that on your own time. But yeah, we're just going to pause now if anybody has any questions, but if not, we'll wrap up the playground, and thank you very much for joining. So just go over to the trusty team's playground helpers. So it doesn't look like we have many questions. I think it might be helping out with some people on the Slack channel. James is just typing, so give us a wee second. Cool. Thank you very much. So yeah, thank you again for attending. I hope you enjoyed the playground and you learned something about compliance testing and how to make it a bit less painful. Yeah, just download the repo, play about with that. If you want to take it a bit further, I've actually included some continuous integration examples in here. So you could go and plug this into a Jenkins setup or a Bitbucket pipelines and actually run these every time you commit to code, and then move the testing onto your actual Git provider, which again is really useful, so you can actually validate changes as they come into your code base. But yeah, thank you very much for joining us, and hopefully see you at the next playground.